Recording. So, class, say I have you're going to have a homework problem like this, please, quiet. So, no, this is not on the notes. This is kind of different than notes. On your homework, Mr. Austin,
Yeah.
there's a van on a hill, and they say how much force is required to keep that van from rolling down the hill. Okay, Gary? So, if the van weighs, say the van weighs 1,000 pounds, okay? That's not very much for a van. But on your homework, the van weighs 5,000 something pounds, okay? Now let's say, in this case, that this angle is 30 degrees right here, okay? And what they do, the reason I'm talking about this, because this has to deal with decomposing vectors, okay? Do you know? I didn't teach you. So on that review sheet, there's something called decomposing vectors using component forms of vectors. So I'm going to go back to that. Where is that? On the note sheet. Can you have, go. So projection of a vector of v onto w is equal to v dot w over the magnitude of w squared times w, and v2 is equal, etc., etc. So what does this mean? It means that, don't do that. We did. It's yesterday's note sheet. Oh, I mean, we can make this big. Okay, so what I'm going to do is I'm going to draw this picture first. So I plus 3j means over 1 and up 3. So if I take a vector that goes over 1 and up 3, that's vector v1. Everyone's happy with that? V1. Okay, that's a v1. And I have another vector w, which is 1 plus 1 over 1 and up 1. Okay, so my other vector is right here, okay? And that's called w, okay?
And both have the same origin.
They both start at 0, 0, yeah. And so what they want to do is, if I want to break what a projection is, I want to break this vector into two vectors, one that goes in the direction of this vector, so out this way somewhere, and another one that is perpendicular to that vector. So in other words, what I'm trying to do is I'm going to get a dotted line here. I'm going to change colors. Let's see if I can do this. So I'm going to get some vector going out this way, and I don't know how long it is, and another vector coming up this way, and I want this plus this to add up to this one, okay? But I want it to be in the same direction as this little one down here. So to figure out what this vector is from here to here, you use this formula, okay? And why you would want to do that, the reason I showed you that ramp problem is because that's kind of why you would want to do this, because if you want to figure out what is the force in this particular direction, you might want to say, what is the force in this direction? What is the force in that direction? But, so want to project it onto this vector. That's what that means. So v1 in this case, okay, is going to be equal to v dot w. So v dot w is 1 times 1, right? The coefficient of this times the coefficient of this. So it's 1 plus what? 3 times 1, which is?
Wait, what is V1? V1 is the line that goes with W?
V1.
Why'd you call that out?
Oh, I called this V1? Because I was confused. I shouldn't have called that V1. I'm sorry. This is V, plain old V. Okay? This is plain old V. This is W. This vector that I'm going to find is called V1. And the next vector that I'm going to find over here is called V2. Okay? So 1 plus 3, that's the dot product of V and W over the magnitude of W squared. So the magnitude of W is 1 squared plus 1 squared, square root of that squared. You guys, that's the magnitude is the square root of the A part and the B part. And if I square it, it's going to take the square root apart times W. Well, W is this, I plus J. So simplifying, so I just plugged into this formula up here. Simplifying that, I get V1, 4, that's equal to 4 over root of 2 squared is what? 2 times I plus J, which is equal to, you just multiply through 2I plus 2J. So in other words, the vector that the length of the vector in this direction is, let's make it solid, okay? Solid green line. Is this is V1 right here. Over 2 and up 2. So it's kind of looking like that. Is that how it goes? Over 2 and up 2? Like that. Okay? So that's V2, this green one with the arrow on the top. Okay? And then, sorry that picture is so squished. And then V2 is equal to V minus V1. So V is this. So I'm going to go 1 plus 3J minus 2I plus 2J. And in order to do that, I subtract the I components. I get negative I. And I subtract the J components plus J. And that's V2. So in other words, V2 is a vector that is back 1 and up 1. So does this look like a vector that's back 1 and up 1? From here to here? There it is. See that? Back 1, up 1. And that vector there is V2. And that's what it is. Okay? And you don't like work? So work is a quantity that's measured. Whoops! I want to get that whole problem done. So work is just what it kind of sounds like. It's measured in foot-pounds, okay? And it's a force applied to moving something in a certain direction. So I'm going to just kind of teach you this one by example. So an object is pulled with a force of 50 pounds. How much work is done in moving the object 100 feet if the angle with the ground is 30 degrees? So the way you do this is, here's the ground, okay? Here's the object that you're going to move. Let's just draw an object. And someone's pulling on that object with a handle, and that's a 30-degree angle. And there's a force of 50 pounds, okay, on that object. And you want to move that object from here to here, which is 100 feet. Is that what it says? 100 feet. So you want to move that object 100 feet from this point to this point. And to compute the work, you multiply the force in the direction of the movement. So this movement it's going this direction 100 in which direction? The I direction, right? You're not moving it in the J direction. So you could say 100I plus 0J if you want to, but it's not moving in that direction, okay? And the force in the I direction, the force is going to be, right? Force, the force is 50 pounds, right? It's 50 cosine of 30 in the I direction, okay? Plus, if you want to, 50 sine of 30 in the J direction. And what you're going to do is you're going to dot product those two things, okay? So you're basically multiplying that times that. But what happens is, what happens to the J's? Right? Since this is J and this is J, there's no work done up or down. So you're really concerned just with the movement in the x direction. So when I multiply this times this, I get 500 cosine 30, right? 5,000, yes, 5,000 cosine of 30 is how much work is done. And cosine of 30 happens to be root of 3 over 2, right? Times root of 3 over 2. So that's equal to 2,500 root of 3, and that is in foot pounds, okay? And it kind of makes sense because you've used so many pounds of force and moved it that far, right? So if you moved it 200 feet, then you do twice as many foot-pounds of work, right? Or if you apply how to apply a force of 100 pounds, then you do twice as much work. And if you lifted it up, instead of lifting it across, then you would multiply the work done in the vertical direction times the work times how much you wanted to move it in the vertical direction. You see that? But all your homework, I think you're just moving things across. So all you're going to be doing is multiplying the I component. Unpause. So a Boeing 737 maintains a constant airspeed of 500 miles per hour due south. So here is the Boeing 737 going straight down that way, and he is going 500 mph. Okay? Shake it off there, Kyle. Okay. 500 miles per hour due south. The velocity of the jet stream is 80 miles per hour, and he's going northeast. So if they say northeast, assume that the angle that it's making with the horizontal is 45 degrees. So we'll make him like over here, and he's going 80. The wind is blowing this way. So this might kind of answer your question, Addie. Okay? And what they want to do is find the actual speed and direction. So if I had this vector and this vector, so if the wind is blowing this way and he's trying to go this way, which way is he kind of going to end up? Kind of like this, right? Okay, because the wind, he's trying to go 500 that way, right? So he's going to end up going kind of like a little short of 500, right? Because he is, this wind is pushing him kind of up and to the side, right? Okay. So what Abby said, does it matter if when I add this and this together, I get this, or should I take the tip of this one and add it to there? Either way, it works, right? So if I put the yellow one down here, yes, you could do this plus this, and that would equal that. Okay. So now I'm going to add these two vectors together, and what you have to do is I'm going to get a dotted line here and change the color. Let's change it to purple, and I'm going to go across like this. So this angle right here, you assume that this is 45 degrees. If it says he's going, northeast, so that's northeast. If they don't give you a specific angle, assume that it's 45 degrees. And so this angle from here to here would be 270, but I'm not going to even worry about that. I'm going to call this vector, like we did in that last problem, negative 500 in what direction? J. Right? That's negative 500 J. But this one I have to break down. Okay? So, and they call this VW for my car. No, they call that for V with respect to the wind. And they call this V with respect to the air. because that's his airspeed, and they call this VG, which is his ground speed, the direction that he's actually going with respect to the ground, the direction and speed with which he's going with respect to the ground. So I'm going to add up VG is equal to VW plus VA. And I know what VA is, that's easy, but VW is a little bit more complicated. So VG is equal to its magnitude, VW is equal to its magnitude 80 times the cosine of 45 in the I direction plus the sine of 45 in the J direction, right? And that should be like that. Okay? Plus VA, which is negative 500 in the J direction. Okay? Now, in order to figure out how fast he's going, I have to figure out the magnitude of this vector. And the way I do the magnitude is taking the square root of a squared plus b squared. Okay? So the magnitude, cosine of 45, that's root of 2 over 2. And sine of 45 is also root of 2 over 2. So when I multiply this through, okay, I get 40 root of 2 in the I direction plus 40 root of 2 minus 500 in the J, that's VG. Sorry, that's not, sorry, let me erase that. That's not the magnitude yet. I'm just simplifying that vector, VG. Do you guys see how I did that? I multiplied this times this gives me 40 root of 2. And this times this also gives me 40 root of 2 minus 500. And this is a J component and that's a J component. I'm putting those together. Now I want to find the magnitude of that vector. And the way I do that is by taking the square root of the square of A plus B. So I'm going to take the square root of 40 root of 2 squared plus 40 root of 2 minus 500 squared. And I calculate that, I crunch that on my calculator, and I get that that's approximately equal to 447 miles per hour.
This is the magnitude?
That is the magnitude. So that's how fast he's going. He's going this way like 447 mph. Now, the other...
7.27 degrees.
And it's 7.72 degrees. How do you get that, Parker?
Use the log cosine.
Yeah, you could do that, but don't tell anybody, okay? So what they want you to do, they want you to find this angle right here, okay? Use a lot of cosines and a lot of sines. I guess you could. I won't tell you that, but you could. So what Abby was saying, I could have taken a vector and what Parker's saying over here too. See this vector, I could add this plus this, right, will give you this. Yes, this plus this will make this vector. So, and this is 500, this is 447. We know that this is 80, right? 80? Okay? And so the easiest way to do that, like Parker said,
And that
is...
angle is 45.
And which angle? Oh, that angle is 45. Yeah. So you could use a lot of cosines to find that angle right there. See that? But the way they want you to do it in the book, which is kind of a pain in the neck, and I would like you to try to do it, is by taking the, you know that cosine of theta is going to be equal to VA dot product with VG over the magnitude of VA times the magnitude, that means the magnitude of VG. That's that formula that I gave you yesterday. So VA dot VG, the way you do that is, where's VA? VA dot VG is going to be, this is VA, right? So if I dot this with this, I just get the J part because the I parts cancel out. So on the top I would get I would get on the top 40 root of 2 minus 500 times negative 500, because I'm just multiplying together the J parts because the I part of this one is 0, and then I divide by the magnitude of VA, which is just 500, and that's an absolute value thing, okay? And the magnitude of VG we found in this problem, 447, okay? So if you multiply this times this, which is the dot product of VA and VG, and divide by the magnitude of this vector and the magnitude of this vector, and then take the inverse cosine, you'll get approximately 7.7 degrees? 7.27 degrees or something. 7.3 degrees. Okay? But yes, Parker's way is much easier. Just go so you would go 80 squared, right? 80 squared equals 500 squared? No, 447 squared. Sorry, it's right in bed. 447 squared plus 500 squared minus 2 times 447 times 500 times the cosine of theta. Okay? And that would be using the law of cosines and you solve for cosine of theta. So you square that, subtract that, divide by that, and then take the inverse cosine of that. So either way, it's kind of mathematically a little complicated, right? So, the end, I think